Downloading and saving is very old computer. Leave it too long, it's no good having to turn it off. I haven't got a new computer for that. I actually asked to have the same computer. Touch wood, God forbid. Still okay. Is it good? Anyway. I don't want a new computer because it still gives me the data that I want. The basic data. Okay. Pick things up, turn it off. Right. Okay, these are equilibrium values. Values in equilibrium conditions. Of course, I cooked up these numbers. Right? We all know this. But things will become a bit clearer when we see the mispricing. Okay? So let's suppose, as Modigliani and Miller suggested, back then in the 50s, actually nowadays people still say the same thing. Investors appear to prefer firms that borrow. Okay? In other words, they put a premium on shares or firms in a levered firm. In our example, let's say Liverco. Okay? And the premium, for example, here, 500, so let's say 10,000 shares, this would make 50 pounds per share, right? So the premium could be 52, okay, or 55. Why would investors value shares or stock in a levered firm more highly than an otherwise equivalent unlevered firm? Why is that? We could think of the WACC formula, the WACC formula, okay? And the maths there is straightforward, okay? I don't want to call that maths because it's practically nothing in there. So basically it's saying that, okay, mistaken reason, that is a less risky instrument. Imagine WACC. Okay, WACC is equal to weight debt, okay, plus this, right, multiplied by weight of equity plus the cost of equity. You'll be in the midterm. This formula will be in the midterm. Write it down. I just came up with it. Come on. Oh, this is multiply. Right. Yeah. Why are you writing it down? Sorry? Is it in the midterm? I admire your attention very much. WACC, we all know this, right? It's just a weighted average. Okay? So the thing is, the argument here is that that is a cheap instrument because it's less risky than equity. Is that true? Yeah. That is less uncertain than equity, less risky. Why is that? Because that is backed up by legal obligation. That is a fixed claim backed up by legal obligation. So of course, it's less uncertain than residual claims or claims held by residual risk bearers. Recall the definition of residual risk bearer from Farmer and French, 1993, three-factor model? No, Farmer and Jensen, 1983. I just tried to confuse it, just confused you. As a practice for midterm exam. Look, Pharma French 1993, three-factor model has nothing to do with agency. It has a pricing model. Right. Let's say, you know, CAPM and with 2 additional terms. That is less risky, so that is cheaper than equity. Right. That's correct, that's fine. That's perfectly fine. So replacing equity with debt. Use less of the expensive stuff, right? Less of expensive stuff and more of the cheap stuff should bring the average financing cost down. This part is a mistake. The math says yes, this should be the case, right? Debt is cheap, use more debt. Equity is expensive, use less equity. If we want to minimize the cost of capital, right? Yeah, the average will come down. Change the weight, but this is wrong. Particularly Miller said that ain't gonna happen. And if it doesn't happen, then in reality, not really. Okay, but of course, if you change debt, equity, not by that much. And of course, in reality, we can only estimate the VACC. So the conclusion, the final outcome won't change very much. Okay? So let's say in the case of black and white change, using more debt will not lead to lower average cost of finance. Why not? This argument, this reason, implicitly assumes that R sub D and R sub E, expected cost of debt and expected cost of equity, remain unchanged as the rates change. Right? As the rates change, the cost of debt and the cost of equity or expected return, right? Expected return on debt and expected return on equity or equilibrium return on debt and equilibrium return on equity do not change. Rates change, R sub D, R sub E don't change. That's the implicit assumption. Okay? So, is this assumption correct? Even in reality. In reality, before we look at the details, in reality, what do you think would happen if we increase the weight for debt? Effectively, volume constant, the left-hand side of the balance sheet, if we increase debt, equity is going to come down. Right? The weight have to sum to 100 or sum to 1. That's it. Okay? So what do you think would happen in reality? Never mind theory. Common sense.
Stay the same.
Sorry?
Stay the same.
Stay the same? Okay, that's one opinion. Finance is a lot of finance stuff, if you think about it carefully, is common sense. Common sense to a lot of people. Change the weights, R sub D, R sub E remain the same. That's one opinion. Anything else?
You would require more return on the equity if you increase that.
Why?
Because then the company would increase ROE, and basically you require more return for more leveraged companies.
Why is required return on equity higher for a more highly levered companies? More risk. Is that systematic risk?
No.
No. Then how come then return on equity goes up?
Because usually if the company is more levered, you'd expect more risk in terms of financing and whatnot.
Yeah. Default risk.
Yeah.
Facing shareholders. Yeah, that's right. That's right. Okay. Greater risk of equity. Okay. Systematic risk here, in this case, this reflects systematic risk, right? That has to reflect systematic risk. Okay, systematic risk is the risk of associated with the risk class of the assets. Okay, so that goes up, right? Although the weight of equity comes down, equity is expensive, right? Comes down, but the cost of equity becomes even more expensive. What about cost of debt? In reality, okay, let's say Chapui Limited goes to your bank. The first million, you charge him 3% or 5%. What about the second million? You're going to charge the same or a bit higher or lower?
Maybe lower because the amount from negotiate always more than.
Yeah, given everything, we can say, you know, several factors would point towards higher interest charges, because collateral would go down, right? Okay, assuming constant productive frontier, the same economy. Right? For example, he owns a Thai restaurant in Switzerland, right, in a town, Chapui Township, right, in Switzerland. The first restaurant, cool. What about the second restaurant? More supply. Demand is constant. Okay, so its profitability is not as good. So think of second restaurant as a second project. Okay, so the quality of this, right, the second project as collateral does not offer as high quality collateral as the first project, right? Yeah. So fixed claims become more risky. So in this case, fixed claimants or fixed claim suppliers would require higher return. Okay, so the cost of debt would go higher as well. Right, so things change. Things about this change as well. In reality, if we increase debt, okay, they're not going to come down. They're going to go up. Right, but this is cheap, this is expensive. The more expensive stuff, it becomes even more expensive. The cheap stuff, we use more of it, yes, but the cost at the margin goes up a bit. And in equilibrium, the USEC remains unchanged. And we'll come back to this. Okay, from a different angle and get at the same conclusion. See, intuition from, I don't want to say different angle. Intuition for this expressed differently. Okay, not using the equation. Okay. Because why is that important? Because they don't like maths, and many other people don't like seeing maths. Mathematical relation, people in general hate it. So when we talk to people in general, or when you talk to me, I don't want to see equation or matrix, okay? Because I'm hopeless at maths. All right, let's say for example, I heard someone laughing. But maths are useful, right? Maths can be useful because a few lines of maths can say a lot of stuff, right? Or a few graphs. If we have to describe in narration, it's going on and on and on and on. Right? Let's use symbols, just like musical notes. Okay. Okay. So let's suppose investors are willing to pay for that mistaken reasoning, £56 a share in Liverpool instead of £50. Okay. So in this case, then the implied cost of equity, expected cost of equity, of course, in Liverpool becomes 70 NI, the same, now scaled by 560 instead of 500. So expected cost of equity becomes 2.5 instead of 14%, right? And with this much of market cap plus 500 of market value of debt, the total firm value of Liverpool becomes 1.06 million instead of just 1 million. Okay. This is a disequilibrium condition. Simply because the first three lines have not changed. Okay, in practitioners' jargons, okay, the fundamentals have not changed. Okay, or the underlying cash flows have not changed. If the underlying cash flow has not changed, how could price change? Because the market is inefficient? I'm not sure. Okay? But here, the assumption is perfect market. So if we assume perfect capital markets, can capital markets be inefficient? No, not at all, not at all, right? We can think of an efficient market. In general, EMH, okay, is an outcome of a perfect market, a special case of a perfect market, okay? Perfect market, everything, little bits and pieces must hold, okay? Little bits and pieces, assumptions must hold, but some of the assumptions, perfect market assumptions, need not hold for the market to be efficient. Okay, that can be frictions, that can be information asymmetry, for example. Okay. So let's take a look here. 70, the same as in table 1, so implied cost of equity is gone down. But the cost of debt remains the same. Why is that? Debt is assumed risk-free. Okay, risk-free rate of return means return on risk-free asset. And risk-free asset means assets that generate constant return regardless of the state of nature. Okay, there'll be a big flood, big drought, cold, snow, hot, heat, return still the same. Okay, that is economic upturn or downturn or during normal time, same return. Okay, do we observe this kind of asset in reality? Do we? You're gonna say government bond? No. But why do people use government bond? As when we say risk-free rate of return, government bond, please. Hey, look that way, government bond. Why? How about the Greek government? Bond issued by Greek government? Would you require this yield, the same yield on the Greek government bonds and Swiss government bonds? No, right? So how could government bond be risk-free? Well, we use them as a proxy, right? When we use something as a proxy, you really need to keep reminding yourself that you're using it only as a proxy, especially in practice, right? Because if you believe that that's a real thing, right? That's a real risk-free rate, you may get your answers wrong, right? Getting answers wrong in class, in exam, you get marks deducted. But in practice, you get your salary deducted, maybe, or you lose your job. Okay. All right. What about rho? Where does this come from? 100,000 divided by this, divided by 1.06 million. Wow, rho has gone down. WACC has gone down. That's the same idea. How could rho go down? What is rho? Capitalization rate, appropriate to risk class. That is appropriate to systematic risk. That corresponds with the systematic risk of the assets. Okay? So still the same assets. Exactly the same assets. So how could rho change? All right, so this is a disequilibrium condition, and Modigliani and Miller argue that individual investors, because individual investors can make homemade leverage, they can exploit this condition. That is, they can try to go for an arbitrage profit, try to make an arbitrage profit here. Okay, that's room for arbitrage, in other words. Okay, let's start from how can we make arbitrage? Start from what we see. Okay, which stock is mispriced? Unliver or liver? Unliver coal or liver coal? Liver coal. Okay. 1. Okay, that's being mispriced. In which direction? Overpriced or underpriced? Overvalued or undervalued? Overvalued. Why is that? Because it is said here. Well done. Okay. Right. So we can try to get arbitrage profit, come up with the arbitrage strategy through taking and closing positions. Okay. Let's say we have enough money only to take positions on 1% of the firm. But 1% is big, right? In reality, it's likely to be 0.000000001%, right? If we average. But anyway, that would be too many zeros. So let's say overvalued stock, liver coal is overvalued. What do we do? When we see overvalued stock, something we think is overvalued, we short. Okay? So we short 1%. 5,600 comes into our pocket. What are we trying to do here? Make arbitrage along the dimension of leverage. Okay? What we're trying to prove here is that individual investors or shareholders, right, can say to managers in unlevered coal, look, you don't need to borrow, we can do that. If you think 50% leverage is good, don't worry about it. Don't do it. We can do it. Can do the same thing. So what you do will not add value. Okay? But if price change, right, we will take advantage of that. We can construct a levered portfolio, right, made up of unlevered stock. It's the same, right? And make money out of it. So, okay, we can show to you, we can do this. We're going to go to stock market empty-handed. We're going to create some money there, right, and spend that money and make some extra money. It's all about money. Okay. Right. Borrow 1%, okay, of the risk-free debt in Liverpool. Right. So we've got 10,600 in our pockets now. All right. We've got levered money now in our pocket. So we long unlevered coal stock. Right. 10,000. 1% of unlevered coal stock. Now, so we have got a portfolio of unlevered coal stock, and that portfolio is a levered portfolio. Okay, we've got 600 left, so we long 600 pounds worth of unlevered coal stock. Our position at the start of the year, at the end of the day, at the stock market, we go there with zero cash position, right? We take positions, we end up with zero cash position. But we've got positions. Okay? So we long 600 pounds worth of unlevered coal stock. Unlevered coal stock is worth 50 pounds per share. How many shares do we have to buy? 12? Yeah? 12 shares? In reality, can we buy 12 shares? So how can we do it in this case? Perfect market. In the perfect market, we can do anything. We can buy any fraction of an asset, right? What is this assumption called? Perfect divisibility, right? Assets are perfectly divisible. Do we need to say this? No, we don't. Right? In frictionless capital market, in perfect markets, assets are perfectly divisible. Okay? Same as in the capital. When you see a model, right, that is based on continuous distribution, anything continuous, right, it assumes perfect divisibility. But in reality, we live in discrete time, don't we? Right? It's discrete, right? And when we investment does not come continuously, right? It's a lump sum. Okay? So there are likely to be jumps. But anyway, continuous model like CAPM would probably do the job just fine. Okay. Taken positions, supposed to be hold positions for a year, okay, for illustrative purposes here, to make in expectation of arbitrage problem, anticipation. Okay, we have taken long positions, well, and short positions. So when we close positions, especially the short positions, we need money, right? So in this case, we need to close the long positions first to get the money. Okay, let's close long positions. Unliverco 10,000 come in. Additional shares in Unliverco 600 come in. 10,600 come in. Okay, plus the known return, fully expected return, 10% and 10%. Right, so now, so far we have got 11,600 coming in. Okay, we have borrowed. We need to pay off the borrowing, 5,000 plus interest. Okay, this much money goes out. Close the short position, 5,600. Expected return 700. 6,300 goes out. We left with 60. Risk free. Because we are fully hedged. We long one and short one. Okay, of assets or portfolio of assets, right, with the same expected return. We long one, we short one to be covered. Okay. Note that the net return, let's see here, on 1% of Unliverco stock, right, net return, okay, from borrowing from on personal account is £700. 10%, right, 10% minus 300, interest 700. 12.5% on 5,600, 1% of Liverco stock is also 700. Okay. Plus we've got 600 extra to spend, right, to make money out of, right, to generate money, to generate additional return without taking additional risk. If you get additional return, expect additional return without taking additional risk, that's arbitrage, isn't it? Right? Okay. Right. So the expectation of the £60 here, right? We drive investors. If I could think of this, anyone being rational, right? In a perfect market, people have the same information, right? Information is perfect. Because information is perfect, people therefore have, or investors therefore have homogeneous expectation. Okay, so we all expect £60 arbitrage, risk-free profit here. So we try to follow this strategy. So we will short Liverco stock and long and Liverco stock until equilibrium is restored. That is, the conditions in table 2 reverting back to table 1. Okay, of course, through the same mechanism, okay, the adjustment back to equilibrium will also happen if people happen to dislike leverage for whatever reason, or dislike it too much, in other words. Okay. Right. Do you think the theorem holds in reality? We know that proposition 1 does not hold. We know. The value of a levered firm is not the same as the value of an unlevered firm. We know that because the assumptions do not hold. Okay? Because in the real world, we live with frictions. There are capital market frictions. But does this mean that the theorem is useless for practitioners? We cannot learn anything from proposition 1? And actually, if you think about risk-free debt assumption, for example, when banks lend, do banks take risk? Do banks take risk really? On average, say in an arm's length transaction, when banks lend, do banks take risk? Jula Co-op, right? Cooperative. lends to Krong Chan co-op, right? A lot of money, yeah? I hold shares in Jula co-op. So I asked, right, Jula's co-op representative in the school, is Jula gonna go down this Krong Chan co-op? I said, no, but we've lent billions to Krong Chan. And this guy said, no problem, right? Because the real value, the market price, okay, or the even liquidation value of the collateral, it was more than the face value of the lending. So debt holders really, in general, don't take risk at all. To me, in the real world, just ask yourself, if you lend, before you decide to lend, right? What makes you decide to lend? There are going to be factors, right, that convince you that, okay, it's safe enough to lend. What does it mean by safe enough to lend? You're going to get your money back, for sure. Okay. So, debt holders in general tend to take a lot of collateral, right? Demand a lot of collateral. Say if the value of collateral is 1 million, if debt holders, if banks think that they can resell this for 1 million, how much would they lend? How much would you lend? Less than 1 million? How much less? Depends, right? Yeah. Okay, if people say, yeah, the fair valuation, fair value, or market, whatever value, right? The same, in the negotiation process, and the equilibrium point is, let's say 5 million. But banks think, it's okay, but we need to make revenue, generate revenue. Okay, if we don't lend, we don't get revenue, right? And we have to pay interest on deposits. It is a bit risky. Maybe we lend, okay, fine, but in this case, we can lend only 65%. You have that? This is an example. You lend 65% sometimes?
About 20.
70? Never below 70?
Actually,
Not below. Okay, about 70.
up to 100.
Yeah, up to 100. Okay. But in the case of 100, it's going to be different from the case of 70, right?
Yeah. Famous name.
Sorry?
Famous name.
Famous name. There's additional collateral. Okay. So if you have whatever model, you try to generalize it, you see a bigger picture, a clearer picture to me. This is my approach. Okay. Right, to non-academic workers. Right? Okay. So what can we learn? Well, first, investors can create homemade leverage. If we know that we can do, let's say we can diversify, right? We as shareholders, we as equity market investors, we can construct a reasonably well diversified portfolio by ourselves. Can we? Can we do that? Yeah, does anyone here not have Excel on their laptop? Do you have a laptop? Do you have a laptop? Do you have a laptop in Switzerland? People have laptop in Switzerland now? Okay. Right. Not just soccer, laptop. Excel. We have Excel, we can construct portfolio, right? Use solvers to solve the weights. Yeah? Follow body gain markets, there's sort of guidelines in there, nice and clear. Okay, so we can try maybe 10 stocks, try to pick 10 stocks, for example, and construct portfolio. Okay, we can do that. So we can do this, and let's suppose we invest in one firm, and this firm says we want to diversify, right? Invest instead of expand, right? Expanding in the current business, you expand into an entirely unrelated business in order to achieve risk diversification on behalf of our shareholders. How would you feel? Do that for what? We can do it. And we probably could do it much more efficiently than what firms can. Because we are individual investors. We can do it in much smaller amount. When firms expand into unrelated business, right, that's a big chunk, yeah, big chunk of investment. And how often would firms have to rebalance? If my firm does this and I'm a shareholder, I would ask, how do you rebalance? What's your rebalancing policy? Every month? Oh, monthly too expensive. Let's think about US mutual funds. About 8 months, every 8 months, you turn over your portfolio. Do firms, if firms have a business portfolio, corporate portfolio, right, of assets like subsidiaries, do firms rebalance portfolio every year? No. So, same thing here. Well, in this case, then the decision to borrow increased leverage basically should not affect expected returns on the firm's assets. Doesn't add any value. It doesn't add any value. Okay. Second, knowing the assumptions and seeing the proof. Basically, we know that now, as practitioners, we understand the conditions that make leverage irrelevant. How many conditions are there? In detail, 9. Okay. What if so in this case then, these are the conditions that make leverage irrelevant. Okay. So if one of the 9 conditions does not hold, then we can start figuring out, right? Okay, what's gonna happen? Okay. So basically, we know these conditions, we as practitioners will know or have a good place to start, right, to figure out how to adjust our firm's leverage in response to market frictions. And what if there's adverse selection? Right. Hopefully we'll get to see adverse selection, implication of adverse selection that we discussed, right, at the start of the course. Okay. Now let's say, given that borrowing does not affect the capitalization rate, does not affect the firm risk class. Okay? If we, as an individual investor or a single small investor, if we hold both debt and equity in Liverco, what would be the expected return on our portfolio? If you in Liverco, table 1, go back to table 1. We hold 1% in Liverco, right? 1% of equity and 1% of debt. What would be our expected return? Weighted average, right, of the expected return on equity, which is 14%, okay? And 50% weight on 6% debt. Okay? So basically this is weighted average of expected return, okay? Which is equation 2. And this is the rule, isn't it? For Liverco, in table 1, what is the expected, right, average return on, or what is the average return on debt and equity? Equity is 14%, right, with 50% weight. Debt is 3%, write that down. You're not going to get it. It's 6%, not 3%. You're all looking sleepy. Me too. You want fried rice and iced coffee to wake you up? 6%, right, with 50% debt. The weighted average is 10%. Yeah, it has to be. What does equation 2 look like? What does it look like for you? From butt fight, your butt fight. All three of you from butt fight. The WACC. So the practice of using the practice of WACC basically comes from the theory. Okay? Actually, to be technically accurate, it is WACC is basically proposition 2. Okay? Because if we rearrange equation 2, okay, say rho is equal to this. Rearrange, right, or simplify equation 2, this part. Rho is equal to this part. We get equation 3. That is expected return. Expected return on equity increases in the debt to equity ratio, holding constant rho, holding constant R sub D. Okay. Can we hold constant R sub D? And let D over E change? Yeah. We can, because of the risk-free debt assumption. Yeah, risk-free debt assumption. What about rho? Rho is capitalization rate or expected return on the assets. Right? Expected return appropriate to the assets in risk class. So that sort of has nothing to do with the firm decision, given that the firm is a price taker. In a perfect market, any single agent is by definition a price taker, not a price maker. Right? Okay. So DO rate can change and rho and R sub D remain constant. Okay. So in this case then, this relation is a linear relation. See, linear relation between R sub E and leverage. One form of a leverage ratio. Okay. So expected return on equity, of course, in a levered firm. If unlevered firm, this will collapse to 0, right? And R sub E is basically the rho. It's the same as unlevered coal. It's the situation of unlevered coal in table 1 or 2. Okay, so expected return on equity in a levered firm goes up linearly with or linearly in the D over E ratio. Debt equity is equal. This is proposition 2. Okay, R sub E increases linearly in D over E. Okay, right. And this whole, given the underlying assumptions. All right, but in reality, as we borrow more and more and more, as a firm borrow more and more and more, debt becomes more risky, right? Fixed claim becomes more risky. In this case then, if we allow debt to become risky rather than risk-free, okay, then R sub D should increase in D over E, right? Debt to equity ratio in leverage. Okay. You keep taking photos. Have you asked me for permission? Not just you, several. Have you asked for permission? If you go to some countries or some conferences, this is a very serious offense because this is intellectual property. Very serious. So be extremely careful. Okay? Be extremely careful. And the reasons I do not give out slides because I want to force you to read the lecture notes, right? And to square up the lecture notes, read the lecture notes, try to make sense of the lecture notes, and square up with what I say in class. I don't want you to go, test of memory and parroting, regurgitating. Right. To me, master students are beyond all that now. Okay. So please practice this. Okay, I know it's hard, it's tough, time consuming, but it's good for your career. Whatever you want your career, however you want your career to be. It's good for your future. Okay? If you don't learn how to read between the lines, read and extract information content, right, from whatever is in front of you, you'll never go far. Never go far at all. Okay? Practitioners, okay, or the big bosses in the industry call this creativity. Okay, yesterday I just got a complaint from one of the big guys in the analyst industry that blah de blah blah, yeah, about July graduates, of course, naturally, otherwise I wouldn't be talking. They wouldn't. He wouldn't be talking to me. There's no creativity as such. So I asked him the details. So okay, I know. Okay, so they call this creativity, but it's about extracting information, content from what they see, right? Rationalizing, okay, and squeezing out the implications for policy, for future actions. Okay. So I got a complaint yesterday evening. Okay. All right. So obviously, if debt becomes risky, R sub D would increases in D over E. That is, the lender would require high interest rate on marginal debt as the firm borrows more. Okay. The question is, does equation 3 of proposition 2 still hold? The answer is yes. Okay, but equation 3 just predicts a slower increase in R sub D. Okay, this is because R sub D increases as D over E increases. Get your hand dirty, plug in the numbers to see what it's like. Otherwise, you never get a feel for it. Some of the things, there's no shortcut, no test of memory, right? And you will not be successful in this course if you just keep trying to memorize it. Get your hand dirty. Once you get a feel for it, okay, once you know how to swim, if you want to know how to swim, what do you have to do? Stay, why not? Like that. Or study just a theory and never do what the theory tells. Say that will happen. If you want to know how to swim, you want to know how to ride a bicycle, you need to ride a bicycle or you need to swim. Right? Jump into the water, leave water and try to swim. Okay, try to get to the other side. Okay, with the water. I'm helping you. But it takes two to tango. It takes two to tango. Okay? I can't tango alone. I need a partner. If you want to tango, well, if you want your partner to tango as well, you need to tango as well. Otherwise you won't be okay? So, how could we rationalize and increase in R sub D, this rho being constant? How could we rationalize that? Rho is constant. Now, if you read the paper, this is proposition 3, but it may be too small for being a proposition. Nowhere near as big as proposition 2, but anyway, okay, let's say this is implication of proposition 2. Rho is constant, still constant, R sub D goes up. Recall our discussion. Okay, So far, what do we see from proposition 1, proposition 2? Proposition 1 say leverage does not matter, has no effect on shareholders' wealth, on the value of equity. Okay? Equity, 1 million, replace half of that with debt. Okay, we end up with, as in table 1, with 500. So shareholders don't lose wealth. Right? Yeah. Basically, they take 500 back, right, and borrow and put in the fund. It's not lower valuation. But proposition 2 says that expected return on equity is affected by leverage. The cost of equity is affected by leverage. So leverage matters then, right? That's what equation 2 says. Equation 3, sorry, or proposition 2. So how can shareholders be indifferent between levered equity and unlevered equity then? Unlevered coal becomes lever coal in table 1, so there's increase in debt, perhaps. As intuition, let's try to rationalize things here. Increase in debt, default risk goes up, and equity becomes more risky, perhaps. But then again, debt is assumed risk-free. Let's go back to equation 3 with the risk-free debt assumption. If debt is assumed risk-free, how could default risk goes up? Risk-free debt means default-free debt, right? You're going to get returned back anyway. No matter how bad the situation is. Well, but debt is fixed obligation by definition. Whatever assumption, whatever type of market, imperfect market or perfect market, debt is a fixed obligation. Think about income statement. Okay, the cost of debt remains the same. The face value of debt, right, instead of being 500,000, what if it's 600,000? Interest rate is the same. Would the amount of interest remain the same? No, right? More debt, more of risk-free debt. Larger amount of risk-free debt means a larger amount of interest expense, right? So holding constant the EBIT, right? Assuming that debt is risk-free, holding constant EBIT. You with me so far? Larger amount of debt implies a larger amount of interest, right? So holding constant EBIT with larger amount of risk-free debt, the net profit would be smaller. Okay, and that implies greater probability of the firm being in the red. Yeah, being in the red. If we allow EBIT to be random, to be risky, okay, or equity to be risky. So the increase in the expected return on equity come from the increase in the risk facing shareholders. In this case, default risk. Okay, greater fixed obligation, greater fixed cost, right? Fixed cost. Interest expense is fixed cost, isn't it? Okay. Of course, such that rho remains unchanged. Okay. So using equation 2, which is WACC, known to a lot of people as WACC, rows of liver coal is 10%. Okay, so we can say that unliver coal row remains at 10% despite a 50% increase in its leverage. Okay, row does not change. For row to remain constant, right? right? Looking backward, going backward. For rho to remain constant, the cost of equity has to go up as unlivable borrows. Right? As unlivable becomes livable. Okay? Rho has to go, cost of equity has to go up. Is that a reasonable thing to expect in reality? Yes, as Chuck Louis suggested, right? Your suggestion, your own suggestion, which you have also forgotten. That's okay. It happens to everybody, including me. Okay? Is it reasonable to expect R sub E to go up is greater than leverage? In reality, never mind the irrelevance. Right? Default risk goes up. So for rho, we can look backwards and say, for rho to remain constant, R sub E has to increase. Okay, so consistent with this view, we can also say that, look, what does rho reflect? What does rho represent? Rho, capitalization rate, appropriate to risk class. So what determines rho? What is the determinant of rho? Risk class, systematic risk, right? Anything else? Let's say for an unlevered firm, how would we estimate the rho for an unlevered firm? In practice, you use the CAPM, right? To get the cost of equity. Cost of equity in a pure equity firm or unlevered firm, right, is basically the rho. Yeah? Okay, so in this case, what drives expected return in the CAPM? CAPM formula. What is the firm specific variable? On the right hand side, how many firm specific variables are there? CAPM. CAPM, not CAPM. CAPM. How do you write CAPM? What's on the right hand side? R sub F plus beta plus expected market risk premium. Yes? Right? R sub F, this is E. E, not F. I know you're thinking about F. R sub M. Right? Sorry, this is M, not W. I know you're thinking about withdrawal. This is M. Man, it goes there all the time. That uncharted territory. This is beta. This is expected market risk premium. How many variables are here? You can say 1, 2, 3, right? Which of the 3 variables here is firm specific? Beta. What is beta? Yeah, yeah, you know it. What is it supposed to represent? Risk? Does it represent leverage? Or risk? Unsystematic risk? What kind of risk? Risk that cannot be diversified. What's the difference between systematic risk and unsystematic risk? Can you give me an example? Firm-specific risk versus industry risk. Which one is more like systematic risk? Industry risk, right? Or the risk of the underlying business, right? Okay, so rho then is a function of systematic risk. Okay? Reflect is driven by beta. It's a function of beta for pure equity firms. Right? Because R sub F is constant, and that at any particular point in time is constant. Across firms, of course. So only beta varies. Okay, and beta is the underlying business risk, the risk of the industry. So can a leverage decision of one firm affect the underlying business risk of that firm's industry? Is that possible? No way, right? A firm is a price taker, not a price maker. So its own decision cannot change the underlying business risk of this industry. Okay? No way. So we can say, right, systematic risk is exogenous to firm. Does systematic risk affect firms or affect a firm? Is systematic risk. Does a firm systematic risk affect the firm or the firm affects its systematic risk? Which one? Which direction you think is the causality? Systematic risk causes firms, right? Firm cannot cause systematic risk. So systematic risk is exogenous to firm decision. What drives role? Systematic risk. So can role be endogenous to firm? Can firm cause role? No. Only role causes firm. What is role? Capitalization rate appropriate to risk class. So role is driven by systematic risk, and if systematic risk is exogenous to firm's decision, how can leverage decision, which is a firm's decision, affect role? Can't. No. Okay, this is the logic. Right? What about the UACC then and this? And the weights, interchange weights. WACC is just a proxy for role. We cannot observe role in reality. Okay? We need to understand in economics and finance what we can observe and cannot observe. Things are different from natural science or engineering. Engineering we cannot observe, but we know this is false. It's been proved. We have discovered it. Right? You jump off the roof, you fall. You're not going to go up. You jump. You try the jumping. We discovered gravity. Okay? We know it's there. We cannot observe, but we know it's there. So we can measure it directly. Can we observe role? Role is a social construct. Finance is a social construct. Right? People make finance. Right? People don't make the law of physics. People only discover the law of physics and make use of physics. Okay, but finance, accounting, economics, people make all this up. So we need to understand the idea behind the theory, and in this case, we need to understand what is observable and what is not observable. And when we say financial tool, basically these are proxies. When we use something as a proxy for something else that we can't observe, there's always noise and room for error. So be very careful. In this case, theoretically, here in theory 2, the UACC is not the role, right? It's just a proxy for role. It's the way in which we calculate, we estimate what we call the cost of capital, risk-adjusted cost of capital, or capitalization rate appropriate to risk class. Okay. All right, a bit more. 2 minutes, 3 minutes, 3 minutes more. Okay, because I'm not going to go through this. I'm going to leave this to you, I think. Well, when corporate tax is allowed, okay, basically firms have to pay tax. Okay. In this case, then, the value of an unlevered firm is given by this equation. Okay, the third line of unlivable, the third line, let's say net income, not net operating, which is the same as net operating income because it is unlivable. Okay, it's the same, basically the same. So we can start from this line, the first line. No debt, no interest expense. Okay? It's no longer NOI 100,000 divided by 0.1. It has to be taxed. 1 minus tau sub C. Okay, if the tax rate is 20%, shareholders will get to keep 80%, or not 100% anymore. Okay. So Modigliani and Miller demonstrate that in the presence of corporate tax, when firms have to pay tax, with tau sub C being the tax rate, equation 1 becomes equation 4. Okay, so the value of a levered firm is given by the value of an unlevered firm plus the present value of the tax shield benefits on interest expenses. Okay, but there's no interest expenses here. Instead, there's B. B is the market value of bond. Is a capitalized value. You may ask me, well, what's the link here for equation 4? What's the link between B and periodic interest expenses? B is the capitalized value or the present value of periodic future expenses. Okay, future interest expenses. Okay, go through the proof by yourself, please. I'm not going to go through because otherwise if you go, yeah, that cancel each other, this and that, move this and that, left hand side, right hand side. Decompose all this. One thing that I want to point out before the break, quick break, is the amount of depreciation and the amount of reinvestment here. We talk about free cash flow. Okay? So free cash flow here is basically free. It's operating cash flow. Okay? You can decompose like this. Okay? Depreciation and reinvestment cancel each other out. Why? Why? Let's go back to what we know. Blank? Short answer. Short answer question. In the proof of this and that, why do the amount of depreciation and reinvestment cancel each other out? To see cash flow? Yeah. But from your butt fight, they don't cancel each other out. When they cancel each other out, they have the same size. Right? Same size. Why do they have the same size? Less than the cost? What constant? Let's go back to what we know. We talk about Modigliani and Miller theorem, right? Irrelevant theorem. Let's go back to the very first page. What do we know? From the start of the session, line by line. Sorry? I can see A plus coming here. No growth. What does that mean, no growth? To replace. They call replacement reinvestment. Right? Depreciation, wear and tear. The asset base, due to wear and tear, erodes. Right? So the firm has to reinvest exactly that amount. Can we do this in reality? But how come this is possible? What assumption? What assumption? Perfect. Yeah, perfect market, but What outcome of the perfect market condition that allows us 12 shares? Can we buy 12 shares? So what assumption is this? Perfect divisibility. Okay? I'm doing this, showing this to you because you need to be able to rationalize what you see. Not just a case of memory. You need to link, square things up, right? Link the end to the beginning, right? Talk about this, talk to your clients, a presentation, to cut a deal. At the end of the deal, the clients get lost, don't know what you're talking about. You think you cut a deal with the client? No, you're not going to get the deal. Okay, you need to call it back. Link it back to, hey, look, you see? You need to be able to rationalize things as well. So rationalize what you see in front of you. Okay, so is blah de blah blah. Okay, and we also see this, basically the proof equation 8 is the same as equation 4. Okay, and look a bit further on, you see equation 9, which is more like the WACC we have to use for valuation at work. Because the cost of debt is not just the cost of debt in our practice, right? It's the cost of debt adjusted for tax. And it comes from equation 9. Okay? So practice in finance, the valuation WACC here, come from the irrelevant theorem, which people say and know for a fact that does not hold in reality. And a lot of university professors, I don't know, this is personal now, in third world countries, or sometimes even in UK or Europe, right? They're excellent at teaching. They say, look, particularly in Miller, yeah, fine, it's a nice theory, but does not hold in reality. But in reality, right, we use something, say a tool, that come from, is derived from the theory directly. WACC comes directly from the theorem. And people say the theorem does not hold. Right? The seniors in your firm will probably say to the seniors in the firm, probably say to undergrads, freshmen, right? Graduates, bachelor degree graduates, that look, you know, what you've learned in school, you know, inside of the university fence is not applied to the real world. Real world is not textbook. But how come textbooks are sold, especially the expensive one, so, and people still pay to do high-priced MBA courses or finance courses? They're simple. Practice comes for finance, practice comes from theory. You understand theory, you make money. Right? Why is that? Because if most people don't know, don't understand this, and you do, it doesn't matter. Okay. All right. Let's take a quick break and talk a bit about adverse selection.